Alright, so in this example we're going to look at solving a trig equation, and we're going to find both the general and specific solutions. So notice that in this equation we have sine squared theta plus sine theta equal to 0, and this is a quadratic trig equation. So what we're going to be able to do at the beginning is we're going to factor out sine theta. And that will leave me with sine theta plus 1 equal to 0 if I factor out sine theta. And now that this is factored, I can set each factor equal to 0. So we're going to have sine theta equal to 0, and we're going to have sine theta plus 1 equal to 0. So for the first equation, sine theta equal to 0, remember that sine theta is y in the unit circle. And so if we visit our unit circle, we can see that there is a y coordinate of 0 at 0 degrees. And then again, y coordinate of 0 at 180 degrees. So if we talk about radians, that's at 0 radians and then at pi radians. And if I keep going, we're going to hit y 0 at 2 pi, and then I can keep going and going. So it appears that the angle is going to start at 0, and we're going to hit a y value of 0 at all of the integer values of pi. So from 0 at 1 pi, then again at 2 pi, then again at 3 pi, 4 pi, 5 pi, 6 pi, and we can keep going and going. So for this first angle, we're going to say theta is 0 plus pi k, where k is an integer. And so that'll get all of the angles that produce sine theta equal to 0. That is a general solution. For the other factor, if I move the 1 over, that's going to say sine theta equals negative 1. And remember, sine is y, so we're looking in the unit circle for where y is negative 1, and that's at 3 pi over 2. So from 0 to 3 pi over 2, and then if I keep going around a full circle, I'm going to keep coming back to this y value of negative 1. So the other angle is going to be theta equals 3 pi over 2 plus, and this time it's plus 2 pi k, because you have to go a full circle to arrive back at that y coordinate of negative 1. So these are our two general solutions in radians for the solutions of the original equation. And so now what we want to do is we want to find all of the angles from 0 to 2 pi that satisfy this equation. So looking at the first one, if we consider, let's consider first k equal to 0. So if k is 0, we're going to get an angle of 0 degrees. And if k is 0 in the bottom one, we're going to get 3 pi over 2. And then let's consider k is 1. So 1 times pi is pi, 0 plus pi is pi. And notice if I let k be 1 in the second general equation, we're going to exceed 2 pi. And so that's not allowed. So k equal to 1 is going to put us bigger than 2 pi for the second general equation. And so then we're going to consider what if k is 2. And so we're going to plug in 2 times pi is 2 pi. That's actually going to exceed 2 pi. We want to look on the interval from 0 to 2 pi, not including to 2 pi. So actually these are the three solutions from 0 to 2 pi, not including 2 pi, for the original equation. 0, 3 pi over 2, and pi. And if we wanted to substitute those back in, we could verify that it does make the equation work out to be 0. But now we've got our general solutions as well as all of the angles on the interval from 0 to 2 pi that satisfy the equation. Man, I hope that was helpful. If you have any questions or comments, feel free to post them in the comments below. And thanks for watching.